In this video I'm going to create a printed circuit board using Fritzing. This is a follow-on from my earlier video where I created a circuit using a breadboard and the schematic diagram, and I'm going to take that design and put it on a printed circuit board that I'm going to have manufactured and then solder the components directly onto that. The Fritzing is a free to use application available on Linux and the Raspberry Pi. It's also available on other operating systems, but you have to pay to download the latest version. Good tool for starting out in, and it can create some nice looking diagrams, particularly for breadboards, but you may want to look in future at moving on to more professional tools for creating printed circuit boards. But for something like this, it should do the job quite nicely. So this is going to be based around my Christmas house project. So first, here's a quick summary of the schematic. It's quite straightforward. These are LEDs that are being driven directly off the Raspberry Pi. Here we've got a MOSFET level shifter, which is providing the 5 volts input required for a NeoPixel RGB LED. There's a switch, a MOSFET switch used to turn on a smoke machine, which is powered from a 20 volt power supply. It's for the chimney inside the house. And then we've got some strings of LEDs, some that are red and some that are green, which are turned on by MOSFET switches as well. And this is how it appears on the breadboard. And as you can see, there's a number of components which are not on the breadboard, and this is because these are mounted elsewhere inside the building. So what I'm wanting to do is to create a printed circuit board, which is going to be a hat format that will sit on top of the Raspberry Pi. These external components that are not mounted on the breadboard will be connected to the PCB using some connectors that I'm going to put on the PCB, rather than having them soldered directly to the PCB. And because of that, I'm going to recommend that you save a copy and start on a new copy. The reason being is that to do that, I'm going to remove all these components and instead replace them with connectors. Normally, if these components were all on the board, you could just carry on as you were. You've got the schematic, you've got the breadboard, and you can start creating your PCB over here. But because I will break the schematic particularly, and I'll be removing some things from the board, they're going to disappear from this view as well. I'm going to start by looking at the connectors that I'm going to use. I'm going to use it on the breadboard view so you can see what the connectors are going to look like. First I'm going to look for is some screw terminal connectors. That's these sorts of designs. Now these are available in different sizes, and the main criteria being the pin spacing. So the ones I have got are 5.08 millimeters. These are 8 amp ones, and they're the ones I'm going to use for the power supply, the 20 volt power supply that's going to connect here. But then I'm also going to create another one using smaller connectors, the smaller pin spacing, which is going to be the 3.5 millimeter pin spacing. The only reason for having these as separate is because it makes it easier when you're wiring up. If the big connector you know is the incoming power supply, and the small connector will be used for this smoke generator. So what I'm going to do is literally just take these and replace these wires onto there, and then delete that, and then do the same on here. So this will be for the power supply here. Red and black to make them clear. And as you can see, it's sort of starting to break up the schematic already. So J1 is the power supply. And these wires, so I've explained this before in the earlier video, the wires which are showed as dotted lines are known as a rat's nest. And what these are wires that are shown in one of the other diagrams as being physically connected, but haven't been connected in this diagram. And this will become evident when we start to wire up the PCB. So if I just connect those there, and this just needs to connect to the ground. So one of the things you can do, I deliberately used a ground connector here. If I duplicate this, and connect that to ground, now these are actually physically connected. Oops. So these two ground connectors here are connected, and that means that I don't have to run a wire all the way around. And then move this further over here. This second connector is going to be the smoke generator. As you can see, we're going to be losing the some of these components, and they're going to be just replaced by these connectors. Go back to breadboard. And all these LEDs, what I'm going to use is a single connector. These are going to be push on, and I'm going to use male pins on the printed circuit board, and they're going to have them in 2 rows, much like the Raspberry Pi GPIO, and then terminate the wires that go off into female connectors that push onto these. So look under the core, and there's a generic connector here. It's female, but I'm going to change that to male. And I wanted to have a double row and 12 pins in total. Now, as you can see for the PCB, it's shown it still as a single row, and that's because a double row one doesn't make sense on a PCB, on a breadboard rather. On a breadboard, there isn't anywhere where you could put a double row and it would be workable. So hence it shows it as a single row. If we look at the PCB, and so I appreciate this just looks a bit of a mess at the moment. We're going to sort all that out in a minute. This is how it looks. Now these are numbered 1 to 6 there, 7 to 12 there. And what I'm wanting to do is to have 1 and 12 as being an LED, and then 2 and 11 being an LED, because that way we can do 2-pin female connectors and we can connect those on. So when we come back to the breadboard, we'll take this first LED. I'm going to use we use this red one first, and I'm going to replace this wire with one. Just delete that. That goes to pin 1. Do it this way. That would replace the pink wire. And the other one that would just go to the resistor here, we replace with a connection to pin 12. And now I can get rid of that LED. And then the same on this one. So just and then we can continue doing the same for the other LEDs. So I'll do the NeoPixel first. I'm going to provide its power supply. Remember, this is the 5-volt power supply first. Then its ground power supply up to the bottom one of those. Then its signal connection go to there. Then I'm going to put another ground connection to this one, so that they should be blank, so that I can use the signal separately. If I wanted to use a separate power supply, I could just take a ground and the data signal from the 2 second sets of pins. That makes sense. So notice that red one, which should, sorry, that black one there should have gone to that rail there. And now I can delete that. And then the same for these. So I'll do the red first. In this case, I can just take that red wire there, and then the female, the ground connection there. Save for that. So it doesn't really matter that this looks a bit of a mess here, because we won't actually be using this breadboard design anymore. That's why we saved a copy. Just delete those. And if we look at the schematic, so now all these, they're shown as ratness wires, are the connections that we need to make on here. Now, because this schematic isn't really going to be much use anymore, because it doesn't make it clear where they go to, and we could put labels on, but I'm not going to bother updating this at this stage, and I'm just going to move straight on to the PCB design, which is the main part of this. So now I'm going to turn this into a PCB design, and we can see all the components have just been dropped in random places. This is the PCB that will be created, and this is the template for the Raspberry Pi, which can be used to create a hat. This works out about the same size. However, if you look at a Raspberry Pi overlaid on this, this is where the USB and Ethernet ports are. So for the hat, we don't really want it to go all the way to here. We want it to end around about here. So I'm going to change the size of the PCB layer. There's the PCB, and the shape, we're going to set the dimensions. Must be 64 millimeters by 56 millimeters. And if we also going to change the grid size, view and set grid size. I'm going to set it to 0.5 millimeter, which is quite a fine grid size. So the first task is going to be positioning some of the main components, in particular these connectors, so that you can get to them. So I'm going to put, this is, so because we've got the connectors here, I don't want to use here, so we can use this side and this side. I'm going to put the two large connectors we've got over here. For the power and for the smoke generator. And then this connector I'm going to move towards the bottom. I'm going to try it in that orientation, and then the connectors would drop on there. And now actually the placement is a bit hit and miss and work through experimentation. Still got an LED on, I must have missed that. The breadboard view. Yeah, okay, so just delete that. Comes down to a combination of personal preference and trying to make the routing of the wires as easy as possible. So for instance, this MOSFET here is for the smoke generator, so it makes sense for that to be near the smoke generator. And then just position these in a more or less straight line so that they look like they've been intentionally positioned there. And then position the resistors around them. So some probably make more sense to be up at the top and some towards the bottom. And although it doesn't matter which way they go, I think it might look a bit better if I can try and keep these oriented the same way. Very easy to click on the wrong component. Just Control Z is the undo key, which I keep pressing every time I make a mistake. I can lock the Raspberry Pi in position so I don't keep clicking it by mistake. Symmetry doesn't matter at all. Does look nice if I can try and make it look a sort of balanced layout. I don't think there's a line option, but one of the things you can do is you can manually type in a location. This is the XY position, so if I make that 16 millimeters, I can make that one also 16 millimeters. It is changing them slightly because of the grid, but there we go. So these to the human eye, they're pretty close, and then the same with these. I'm going to save at this point. There's two options for doing this. You can either manually route all the wires, which is probably the one I'm going to end up doing, or you can just click on auto route and it will try and automatically route all the wires for you. Let's try that first. And it's taken a while to try lots of different permutations. So there it is, all wired up, except it's missed quite a few connections, so they'd have to be done manually. Anyway, I think the problem is the thickness of the wire it's used means that they're going to be crossing. Not really impressed with that, so I'll just undo that and I'm going to do this all manually and have a go and see how we can do something better. So I'm going to start by looking at the big components, and remember we can always move any of the components around, so these aren't fixed positions, these are just what seemed to make sense at the time. The other thing to bear in mind, we have got two layers, so at the moment it shows both layers, and one will be yellow, one will be orange. Start with one layer, and then if we can't complete it there, then we switch to the other layer, and then if we can't do it like that, then we add vias, which are paths that go from one side of the board to the other, from the front to the back and vice versa. This is the power supply, and I've just drawn that line. There is an argument against sharp corners, so as you see this isn't a 90-degree bend. I think whereas on the schematic the 90-degree bends looks really nice and makes it tidier, there is an argument that that can cause more crosstalk. On a circuit like this, and we're talking low speed communications, it's not going to make much difference. If you were creating a circuit that's going to work in the megahertz, then potentially you're going to have a lot more problems. I'm just going to stick with having softer angles than 90 degrees where I can. Also worth bearing in mind that these will be sort of visible. They're going to be covered by the colour screening, so they won't stand out hugely, but you will be able to sort of see them when you look at the board. I'm going to try this one to this one. I'm going to bring it around the outside. Oops. So these have been left at the default size, which is the standard 24mm, and these are the main power lines, so I'm going to leave those at this, but the other lines that I used for the smaller connections I'm going to make smaller so that I can wire them between or around the board as I need to. Let's got one in around here, so that's got a really sharp edge there. So if I can flatten that off a little. So as you see here, we need this signal line here on a different layer. So I'm just going to draw it first. I'm going to change it from the bottom to the top layer, and I'm going to make these thinner because we don't need these signal lines to be quite so thick. And then really it's just a case of just choosing, yes, I'm fairly sure these must be the ground connections. And actually, that one's a good one. That one just needs to connect to there. So I will actually create a ground plane as well, which will cover all the remaining area that's not part of the ground, which is usually a good idea for, again, reducing the amount of noise. And then drop that to the thinner size. There's connected. I'm just thinking if I run a connection from there to there on the bottom, I can run it through this gap here. And then that's connected there. And that's, I'm going to put that as a thinner line. So now the difficult bit's going to be crossing these and this, so we'll come to that in a bit. And there's one that needs to go all the way from there to there. That one we can do on, I'm going to put that on the other layer, onto the top layer, so thin, because then I can connect it to that using the same layer. It's going to cross there. That then needs to be on, I won't do that just yet. This needs to be on the orange layer so it can cross there. So that one's going to have to be yellow to work there. Put that on the top layer. And then this one if I make this yellow as well, I can route it through these resistors here. Without crossing anything. At this point, I try to wire the tracks between the pins of the GPIO. Unfortunately, this failed the design rules check at the end, so I ended up rerouting them around the outside instead. I have seen circuit boards where wires have been run through those. However, I believe this is a combination of the size of the pads for soldering and the design rules that are in place. So it's not possible to do it in Fritzing without at least making some modifications to those. And we just keep going on until we've done as many as we can without crossing. Now we're going to have some problems with these. These are going to have to look at putting some kind of wire in at some point. Just looking at this one that goes from here, I'm wondering if I connect it from here instead on the yellow layer, then I can route that without crossing anything. That's a 5 volts, so it can go to that one. Fine. Now it's going to have to cross these here, either cross them here or cross them down there. Got to make that slightly thicker as well. This is a power line, the 5 volt power supply. So as you can see, the issue is going to be here at the top. We've got lots of lines that need to cross each other. We've got these two. So these are for the individual LEDs. Now I could actually swap those round from the point of view of the connector. I could say that would make it easier. That would go to that one, and then that one would go to here. So that's going to make it easier. I hadn't fixed that as such, so if I go to the schematic, I sort of did it on the breadboard. So these are the ones that go direct from there to the LED. So if I just temporarily move that one to there. No, that's wouldn't do that in real life, but move that one to there, that one to there, and look at the PCB, and that's going to make that a little easier, hopefully. So I can route that using the yellow. So we've now fully routed, and as far as I can see there's no issues. So the next thing is to add a ground plane, and that's from the routing menu. And what the ground plane is going to do is cover all the unused area of the board with copper that's going to be connected to ground, which is this connection here, and that will mean that it helps to reduce any noise that's going to get induced by these connections. So I choose the ground fill seeds. See, there's one here which is called ground. That's because we added that ground symbol in the schematic diagram. So you can just select that and then OK and ground fill. It's going to put a ground fill on both layers. And see, there's some areas that it's missed out, and these are areas where it can't reach, but those are negligible. Yeah, looks like there's connectors going through. Look at the bottom layer separately, so there's a ground. So this is to be able to connect these two areas. It's provided these connectors. It looks like we're now ready to send this for making it into a PCB. So the one thing we do is need to tidy it up and get all these labels. So these labels are things that you will see when you're soldering up, so you know which connector to put into where and what the different wires do. So we'll just have a look at tidying those up. To change these, the first things we could do is we can select them as you could do on the other layers. If you select the components, and you can just move them around. So we can just move them, rotate them. And we can rotate them just as we could. We could also have these display the values if we wanted to. Make it easier when you're wiring it up to know that you're putting the right resistor in. Could reduce the font size, which might help. That looks a bit better, I think. It's going to make it quite difficult to read, but it's going to mean that we can see, because you only need these when you're actually soldering up, as opposed to these, which will be useful when people are wiring, connecting to the board in future, if you have to reconnect those connections. So I'm going to carry on doing this. You don't need to watch me doing each individual one, but one of the things that you can do is also add some text and select an image. Tell people what the board is about, things like that. So we're still on the top layer. I'll just make sure the top layer is active. I'm going to put a image here, and this is going to be my Penguin Tutor logo that I use, and I've actually created an inverted image, so that's what it looks normally. But I've created it inverted because this actually inverts it. So there we go, so I can mark it with my logo and then add some text to describe what the board is. So this is a Christmas house. Can scale it. There we go. Maybe add a version number. Yep. Okay, so end up creating an updated version. And perhaps add my website, perhaps running up there. And as with other parts, you can rotate and scale it. Okay. So now I'm just going to carry on modifying all these and making this just look nice. So as you can see, I've now tidied it up. I've added some extra labels to indicate where the positive supply and the ground supply is. I've added some extra labels around here to indicate which pins of the connector go to which ones, and I've rearranged all the labels to make it look nice. So that's pretty much it complete. So it does include a design rules check, so we can run this and see if there's any this concern is probably this wire here. Yeah, so it is a bit concerned it was a bit too close. So I select all copper fill and just press delete. So we'll re-add that back in a bit. So it looks like that would actually be quite easy to reroute over the top instead. So that should be that one. So looks like somehow that line got moved. So yeah, there's some definite issues here. So let's just try. Oh, I think I've accidentally moved this whole top layer. That's what's done that. So try repositioning that. Before I do that, I'll just relock this because it should have been locked to the PCB so it doesn't get moved. Let's try say this one. I'm going to make it super fine. And run the design rules check again. That one has now passed, so let's do it for these other ones. I'm going to try rerouting some of these around the outside instead. So this one, I can put it on the orange layer, but I'm going to have to cross over, sorry, on the yellow layer, so it doesn't, but then I'm going to have to put a via point in here. So route it via this way using the bottom layer. Then I'm going to have to do something similar on this one. It's got a long way. If I take this one, I can route this the entire way using the current layer. And then if I put a via in here, you can go via the orange bottom layer to here. Then this yellow is to come up to here. Yeah, so now we can try running the design rules check again. Okay, so that's it. So in theory, it should have been possible to go between these. However, I think it's safer to try and get it so it doesn't. I'm just going to move these just a little bit now so that that doesn't have a line going through it. And then I can re-add that fill in, the copper fill for the ground plane. That's looking better. At this point, it's now ready to send to a fabricator to have made up. However, before you do, I suggest you spend some time checking over, make sure there's no wires that are crossing that you've missed, that there's no missing links, that the components fit. So one of the things you can do is you can export the images as PDFs, as images, as various things. For instance, you might want to print a layout showing the PCB and then make sure that all your components fit. In particular, for instance, these two connectors that have got different sizes, make sure that they do actually match up with the particular components you've got. And then once you are ready, you've got two choices. So one option is to send it to Fritzing They're a fabrication company to get it printed or to get it etched, and they are not, however, the cheapest, but in return they do make some extra checks, and I believe they're based in Germany, so those in Europe, the prices here are in euros. I'm not sure whether they've got any fabricating plants in other countries, but it means that you don't have to worry about customs issues or delays because they're printed locally. However, you'll probably find you can get considerably cheaper if you have them manufactured in China, particularly if you're wanting to order a lot of them. So it's up to you who you use. I'll probably use a different provider here, but if you want to just fabricate using Fritzing, then they do make it nice and straightforward and simple, and they do some additional checks, so that's one thing worth considering. If not, then you can use the export, and you want to choose export as production and extended Gerber file, and this will create a list of files. There's probably half a dozen, more than that, files that it creates, which describe each of the parts, each of the actions that the fabricator has to do. You'll have to zip that up, and you might need to add some extra text files which describe some parts, and you'll have to read the instructions from the company that you're sending it to, what they expect to see in their Gerber files. So that's an option and can be cheaper. Now, how many do you have made is the next question. If you're just creating a few for yourself, then you might just have it all made in one go. If you're looking at creating a production run and you're going to make them for sale and you want to print hundreds, then I suggest you have a few made first and test them and make sure you go through various versions, make sure all soldered, make sure it all works before you spend the money of getting hundreds made up. So that's it, and my next video, hopefully I'll have some printed circuit boards back and I can show you about soldering it up, and we can see if it works. If you haven't already, please subscribe to my channel to get notified when the new video comes out, and hopefully see you then.